Okay,
right.
we are here for the fourth episode of the All Things Facades podcast. We decided on this one to go over the pond to visit Eugene Korch over in the UK. So funny enough, I came across Eugene via his content on YouTube, and he is phenomenal in terms of breaking down various facade system types and going into performance and design and detailing. You know, Eugene and I discussed ahead of time that he's a very visual person. So I think this episode is going to have a lot of visuals and detailing via isometrics and section cuts on the screen, which will be good for YouTube, but we'll do our best to talk through it for anybody listening via audio. So Eugene, want to give you a quick 60 seconds to kind of introduce to everybody who you are, your background, and where your interests are.
Right. Thank you for having me on the podcast. Really excited about that. I am a facade engineer. I am a technical director of Facade Institute of Technik. And I'm a course leader in the Institute of Science and Technology, Architectural Science and Technology, and I lead a facade engineering course. It's called Applied Facade Engineering, that's pretty much my background. Probably everything else will be uncovered during the conversation.
So I think it'll be able to help. Obviously, our accents sound a little bit different. So I guess to share with everybody your upbringing and where you grew up and where you practice and study and your experience comes from.
Well, it's a very complicated thing, but then most of my career is and where I gathered the knowledge is in the UK. I'm practicing facade engineering for about 16 or 17 years now, and predominantly it's all around facades. I have a background in mechanical engineering, but also in architecture. I studied in the UK. And practiced a little bit in UAE, a little bit in Europe and Germany, and in Eastern European countries. But the bulk of work and the bulk of project I'm involved in and was involved are in the UK and predominantly in England.
So it's interesting. My background's in mechanical engineering as well. So do you see things from more of an engineering performance standpoint or on the architectural detailing design standpoint?
Just engineering, just pretty much engineering. I try to remove myself from how the buildings look, and I think in the context of that, of the conversation I'm going to have, it will become clear why. I'm probably going to just introduce the topic that we discussed in a way, and talking about the differences and not only the accent, but listening to your previous podcast is also the terminology, which I think we just discussed before. That was quite funny to hear that what you guys call design assist, and we call here PCSA, Reconstruction Services Agreement. Obviously, this hilarious aluminum thing, as you were saying.
Pre-construction service agreement. So right on our episode around prefabrication and how design assist is becoming normalized in the industry, this whole concept of pre-construction service agreement, has that been around for a long time?
It's been around for a long time. I think that's how probably the industry now steers towards to, especially what we have in the UK with this new regulatory thing called Building Safety Act, in a way that we need to now design all of the buildings to a much more advanced design stage quite early on, which is pretty much only possible with facade specialist contractor being on board very early. It's virtually you're designing the building up front, so there's kind of really streamlining the concept stage straight away to design for construction. So that's where the pre-construction service agreements and design assist, as you call it, pretty much is the only way forward. And it's very important to select the type of facade that you're you're going to employ on the project at the very, very early stage. And lots of issues can be seen when that selection was not carried out properly, and a lot of contractors, main contractors and clients are stuck with the implementation strategy of the facade that is not suitable for the building, and a lot of money is wasted, time and resources, which probably can be avoided quite easily.
So what's interesting is my experience is here stateside and has been predominantly in New York. As I say on previous episodes, I came up in the unitized window wall and curtain wall world, so that is quite normal to me.
That's the kind of a type of topic I said is basically that nothing is what it seems, and I'll a little bit explain what I mean by that. So this, for example, is the world renowned and an iconic building, the Battersea Power Station. It's the world's largest brick structure. And this world's largest brick structure is actually not a brick, it is a precast. When it was redeveloped, it used to be a power plant, now it's a precast concrete building. And one of the, you mentioned Techrit already, but then there's a contractor called Thorpe Precast. That image is taken from their website. When you look at, and another one is contractor Zealy, it's actually, being a brick building, it's actually not brick at all. It's a glass unitized and stick curtain wall and the precast concrete. So why nothing is what it seems? It's not only happens in London when the facades are just they redeveloped and they're changing the facade type. For example, this facade looks like a precast concrete building. It isn't. It's a unitized, prefabricated, where the outer layer of the facade is just purely wallpaper, purely veneered glass reinforced concrete. The bulk amount of work is done by the unitized that you are known to you, and the veneer that looks like a precast and is prefabricated, it's actually GFRC cladding, glass reinforced concrete. So nothing what it seems. How did we get here? So we got here, and now I'll just go through what happens in the UK. The buildings, not necessarily the old ones, or it's when someone looks at the building, one type of facade, one outlook of the building can be executed in quite many ways. I know that in States you don't build in somewhat traditional drained brick cladding as much, but most of the brick building facades in London and the UK are actually drain cavity masonry structure. It also can be brick slip and look exactly the same, or it can be a precast concrete and still look exactly the same. It's not only limited to brick. An aluminium or glass facade can be done again in punched window life steel frame. It can be done as a unitized and looks the same, and can be done in stick curtain wall and a mixture of rain screen cladding, and it will look the same. The question
is, before we dive into the different system types, I guess what I'm getting at is, or what I'm gathering from what you're saying is, there's a lot of different ways to achieve an aesthetic via different means of system design. But to take 10,000 steps back, it sounds as though we're getting into very advanced topics, which what I'm getting at is it feels like that's commonplace or normal building practice for you in the UK. Doesn't seem like these are one-off projects.
These are, yes. Before this pre-construction service agreement happens, or before design assist, you need to figure out which facade type is suitable for your needs, and there's many ways to skin the cat. So in that sense, all of these facades, they are not they're different pros and cons, but they are all suitable for different applications. So in the UK, what we see is that the driving factors are not the look. Not how the building looks is the driving factor, and not necessarily sustainability. The driving factors become different, and the peril of going in the pre-construction service agreement, in the design assist with the not suitable contractor who is not necessarily suitable for the building is huge. You may lock yourself in this. So what happens right now is that when the design concept is being given to a facade engineering company or a wide variety of, or a facade specialist who specializes in variety of different assemblies, a certain optioneering goes through. The certain optioneering happens as a stage. All of these facades, there's what I just been through. It's about 5 types of facades. And in our course, I go through all of them, and it takes about 2 weeks to go through during the course. So we don't have enough time. What I want to say here is that all of these facades, they can achieve the U values, the structural performance, the condensation, or what have you. So all of these 6 types of facades, they achieve it differently. The vapor control layer is in one location, there's the double stage seal happens at different level. They all work differently. The movement tolerances happens differently. These are all advanced topics. But what's interesting is that what we find as the driving factors for all of these facades are not their how they deal with the and achieve the performance and compliance with the requirements. So what would be the driving factors? And we find that predominantly in the UK, climate is always the same. In States, that will be a huge factor. So UK, there is one climate more or less, but the height of the building and the size of the building, and to a certain degree, the geometry would be the driving factors. If you would say you're going to go for what our meat and potatoes would be your very small residential building that you probably would be executing in a timber frame, you're not going to gain anything by prefabricating getting to unitize. So you're going to go with the masonry drained cavity. And why are you going to be doing that? Because you're going to be installing that from a scaffold or a mast climber. Oh, sorry, not mast climber, but the mobile platform, the scissor lift in that sense. You're not going to get any advantages of having anything else. Once you slightly increase the building size, if let's say it's going to be a 5 to 4 stories building, you still go with your access via scaffold, and it still makes sense to use drain cavity masonry facade. It still offers the speed, but then at some point, sequence of installation becomes a driving factor, a concern, a limiting factor. If the windows are stacked, as you can see in this facade here, they're one window on top of another, you still can go with your with the scaffold and your traditional masonry. But if windows are staggered, as you can see here, and you have access via scaffold, then you will have to now install masonry support at every floor slab. That becomes expensive. Cost is another limiting factor with the different facade assembly like that. But in that case, it probably makes sense not to go with the masonry support at every floor slab, but with the rain screen. Masonry, which is used just brick by brick, and you're restricted to how many people can work per floor, and your material distribution. Rain screen is much lighter, so you're going to.
So do you think labor plays into this, or
Huge.
Availability, meaning in terms of your how many masons you have, or having a prefabricate offsite? Wouldn't that propose a benefit, whether you're doing some type of rain screen mega panel system versus a brick inlay precast panel? Where would the advantages be of doing a hand laid brick job on site?
Size. It will be size of the project. If your project is just very small sized, like let's say, if that would be just your 5-story building, finding a precaster for a small building would be a challenge. But if you're in London and if you're having a building of 5 stories, either of those two methods of constructions would work. You would find labor. If you are somewhere removed in a remote location, that may be a challenge. Where the prefabrication kicks in the UK at least, is where there's actually is the not probably the labor is the driving factor, but I'd say the height and the how it's positioned. For example, this one would be for 8 stories high construction for 12 to 15 stories. If you're gonna go with this assembly as a rain screen cladding, as a brick slip, you would need to build a scaffold, and labor would be a concern, but from different perspective. It takes about 2 weeks to build scaffold for 1 floor and 1 week to strike. So if, let's say, you have a 15-story building, you are 45 weeks of just providing the access for the building without actually building anything. Okay, fine. You can just use the mass climber to install your rain screen. You say this 45 weeks to providing the access, but you still have at least 3 weeks per floor to install your facade. But the problem with mass climber is you have only 1 floor to work with. You can't work on many levels simultaneously. You're stuck. So that becomes an issue. In that case, if the building looks like what this one looks, it makes sense to start prefabricating it, and you're going with mega panels, precast concrete, I would say, precast concrete panels. This, for example, a building looks that is suitable for using a precast concrete, a sandwich panel, completely prefabricated, where not just the facade being prefabricated, the whole building is prefabricated. There will be a load-bearing structure inner leaf of that precast panel that will be holding the slab. In that case, you can get your week of floor of entire building being built, and you can use a tower crane. You don't need to have anything else as external access. You can build the whole building. It's prefabricated.
So what if you're fighting for tower crane time? Meaning, are you waiting for your cast in place structure to be topped out? And when are those precast panels actually being installed?
Well, in that particular one, you first install the wall, which is a precast concrete panel. That's the entire thing is a precast concrete panel with the core bolt that rests the slab. So in theory, your tower crane or 2 are installing the entire building, so you don't wait for anything else. And when you mentioned that, for that building it works, but this type of assembly works for like student accommodation, when it's highly repetitive and the panels are all the same. And that brings us to the next section, when if you have a super tall high-rise with thin levels of everything, and there's a lot of other different materials, with your terracotta, brick slips, and the rest, and there is no repetition, or very little of that. In that case, you are installing it as a unitized, and you are very familiar with that. And I would say that, probably Manhattan and New York, I've seen a lot of that happening. When you use it as a unitized facade, as a unitized curtain wall, you don't fight for a tower crane. You install it for the mobile crane, installed from the floors above, and the floors below, the operatives maneuvers in place. You have far less people to do that. That works very well until you no longer can do it. It doesn't work all the time. The prefabricated facade always has restrictions for how the building would look. You have to have certain level of repetition. You're going to have your joints seen. For buildings like this, when everything is staggered, everything is very thin, you would not be able to build this type of facade with your window panel system. Not mega panel, nor the precast, because that's how they would look. You would be relying on window to be pre-installed in the donut of the precast panel, or a mega panel, and that was I've seen quite a lot of people are doing in across the pond. Which is a very nice system. We don't have that here. We have predominantly precast. We don't install mega panels, and probably lack of ability of contractors, or there's no one really just getting that in the market. There's probably.
But when you say mega panel, this precast donut in essence is a mega panel. So when you just mean various forms of mega panel out of like a cold rolled steel or aluminum backed system.
Cold rolled steel. I thought that's what's referred to mega panels in states, when you have a steel sections to form huge panels. And I thought it sounds nice.
let's go back 2 slides, and this is the topic I want to get to with you. So yes, this is perfect picture.
So I brought up the topic of wet sealed versus dry sealed systems, or wet sealed as in sealant, that's what's sealing your joints,
Hmm.
versus gasketed systems like unitized curtain wall. And it's just a different method and means of construction, designing, and weather or water management. I want to go into some of the pros and cons of each approach. And before I ask my next question, what would you call that over in UK, the difference between those two systems? Because I know we had a confusion in terminology.
To be honest, we still don't know how we call it. I mean, probably uh, no one really brings that as a topic of conversation. That's why I was kind of taken aback a little bit, because like, what is wet seal? What's dry seal? The sealing in general, how you seal the joints, is not necessarily an issue. I would say that the issue that is discussed. What you mean by, I guess, wet seal, it's when silicone is applied between the joints. Is that?
Yeah, well, let me ask you this. I mean, let's take them one at a time. How is a unitized curtain wall system managing water where you have a gasketed connection at the stack joint?
Yeah. Well, it usually is done with the. I had probably an image here. So that's basically, that would be the gasketed joint. There's a two-stage seal, a stack one. So you have a first stage here with a gasket connection. Sometimes there's three gaskets connected to each other, depending on the system. This one is just shown generically for the purpose of studying it, teaching it at the course that I lead.
So this is what they call a pressure equalized system, and you have a cavity for your secondary means of drainage.
Yes, that would happen here. That would happen on that element here. But the difference is exactly as you said. There's a two-stage seal with the pressure equalized cavity. That's how windows work. That's how even to some degree the stick curtain wall system works. And the unitized, it's just they arrange it slightly differently.
So that's what we call gasketed or pressure equalized system, or
Right.
dry seal. Now let's go to the wet seal, talking about a precast panel, which relies on multiple lines of silicone, and in essence is a barrier to keep your weather out.
Right. The precast would have this kind of assembly. I mean, it's not, can't zoom in on this one, but then in theory, the silicon is applied as a 2 or 3 stages. Again, depends on the manufacturer. When there is a backing rod installed, first layer of silicon applied continuously without interruption, without intermissions, and the second layer of silicon is applied to create that chamber, and it's also drained in certain locations, sometimes horizontally, sometimes vertically, sometimes both, depending on the who is the contractor who is doing this. We don't see any failures with either. With prefabricated facades tend to be performing slightly better, I would imagine, than the in situ installation methods.
Correct. And I'm
But
playing devil's advocate here. So you install this precast donut on site. So that portion is prefabricated and you're minimizing your joints. But all of these interface details where the two panels interlock, that multiple stage of sealant, that's site installed, and you're
yes,
solely relying on your quality control on site to execute that joint.
and it's very difficult as well. I'm glad you brought that up, because the issue with that the access for precast concrete panel installation happens when you're sealing effectively and doing any finishing touches with the rope abseiling. So when you get an operative suspended from the rope, installing some bits and pieces around the joints, or if there's a lower rise building, you do it from the motorized access platform, MUPS, or your cherry picker or boom lifts, and that becomes a very difficult element to police because there is
So
no one.
they wouldn't hang over a scaffold to seal the joints. They would do it via rope access.
Usually, yes. In the UK, we see it quite often that this is done by rope abseiling rather than a scaffold. Because if that's, let's say, a huge high-rise building, uh, installing scaffold defeats the whole point of having prefabrication of that facade. So we see quite a lot. It also can be done via cradle, suspended cradle. These are seen by some as less safe, and but nevertheless can be used. Or if the building is accessed via a building maintenance unit, BMU, it can be done via that element once it's in place. Not every precast concrete building is later on accessed as the building maintenance unit when it's completed. So
Sure. I
sometimes
mean, I'm trying to think about, I can understand an interior glazed window where you would replace broken glass or damaged glass from the inside, but regardless, there's still some components of the facade that have to be accessed from the exterior. So in your curtain wall, you have window washing tracks, and having a building maintenance unit from the roof is commonplace. But on a precast or a wet sealed system, I'd imagine even to replace those joints, at some point you have to get access to the exterior.
that's right. The access for maintenance is a very, very important topic, and this, which is very often is overlooked at the original stages of the design development. I would say that it is rope abseiling for the buildings that would be less than, let's say, 5 floors or 8. It's probably not financially feasible to have a building maintenance unit to be positioned at every building.
Sure.
Probably again, also there's also, depending on the shape of the building, you can get a building that is shaped as a, I don't know, as a gherkin in London, or as a mayor office, which are effectively spheres or an egg shaped. You can't have a building maintenance unit. Or Shad in London has building maintenance units installed at every, I think, 5 or 7 floors. That becomes expensive because it takes in the internal space of the building that potentially is not used for anything that you can charge money. It's basically a dead space for, and it also, you just pay for maintaining it. So the shape of the building becomes a very important element. But in precast concrete, other than maintaining the joints, there isn't much that could go wrong. The glass is installed from the inside anyway, because that's windows, and you could easily install the glass from the window, so that would not be a huge issue. In changing a flashing or a sill underneath the window and maintaining the joints, potentially need to be replaced every 12 years, let's say. So that could be easily done by rope abseiling. So I would say
Do you see a lot of in-swing operable windows in these punched applications, or outswing? Because it's very climate dependent. We install a lot of in-swing and tilt turns here in New York. A lot of people like to be able to clean the glass from the inside.
yeah.
Plus, we have your ventilation requirements. But I go to other cities and you just see those zero sightline awnings or just outswing windows. So it seems to be very market driven.
It's both. I don't necessarily like the outward opening windows. Actually, in our course, we provide quite a lot of reasons why that not necessarily is a good idea unless it's a scissor mechanism, and that also has a certain restriction on the size. Inward open window are much more convenient, again, for maintenance and also safety. You never want to have an outward opening window. They're still not legislatively forbidden in UK. And if the restrictor is installed, there's basically very difficult to police, at least unless it's a hotel, if the residents would remove a restrictor, and in high wind, this window can be ripped off the building, and terrible things can happen. So actually, I always recommend only inward opening windows.
Sure.
Yeah.
Okay, so the biggest drawback or challenge in your eyes, from what I'm gathering, with this prefabricated, pre-glazed, precast approach on site is the limited access to install those joints.
Yes, the limited access to install those joints, but that I don't think is a huge challenge. It's easily overcome, and I haven't heard any issues with that, and I don't recall any failures with that either, to be honest with you. So I wouldn't necessarily flag it as a drawback or a disadvantage of the system per se.
Sure. Okay, so let's move on now to the gasketed approach. So this whole rain screen concept, unitized curtain wall, it in essence still relies on sealant joints to be executed on site, especially at your stack joints, at the chicken head. And so there still has to be a high level of quality control in the field. And I'm guessing you smiled there because I said chicken head. I don't know if that's a term that's used
I've
over
heard
in the UK.
that. I've heard that but in only in States, because it's a chicken head approach, and also the sword curtain wall. I think the sword curtain wall unitized is by far the most popular in Europe. We don't see as many chicken head ones, and they are kind of a proprietary system by certain facade specialist contractors. It's like their own system. But the off-the-shelf systems, they're usually sword spigoted systems.
Sure.
So the chicken head is pretty much that's what was installed in States. I would imagine. I don't necessarily see. I know that they're different, but they're just different. I don't necessarily think that they are somewhat better or worse from one another. I'll try to dig out because it's very difficult to explain a system that without actually showing how they operate.
As you're pulling up the details, do you run into issues with thermal requirements and energy codes complying with highly glazed facades in the UK?
It's a difficult. I think it's a commercial issue rather than a thermal one, because it's not many people can afford the triple glazing, and it's a commercial issue. Even if you push for triple glazing, which makes a lot of sense.
So you see triple glazing getting valued engineered out of a lot of projects.
It's not even being engineered. That's the thing. So the one, if you can see the elements. So that there's this sword one, and that's a chicken head. Did I understand you correctly? The one on the right.
Sword versus a chicken head. Sure. Yeah, the one on the right is what I was referring to as a chicken.
Yeah,
correct.
So they're all gasketed in a way. So I don't necessarily see that how they would be entirely different than when they operate from the operation. But the bracket would be all mostly the same. So what would be the challenge, you think? What would be the difference between
I
those?
don't, and this is something that you hear a lot from designers and facade consultants having concern about the precast system or the wet sealed system solely relying on those joints being executed in the field to keep your facade weather tight. Whereas what I've heard is, in theory, with this gasketed system that's pressure equalized and has sort of that cavity as a secondary means of water management, you're not as heavily relying on that field execution to enclose the building and keep it weather tight.
That is true, but they both can fail. The gasket can also fail, and for example, there are limits to the movement intolerances. The both are different in their movement. If I will just share a screen again, I'm very sorry because it's very difficult for me to explain certain aspects. So when the sword system deflects, it deflects in parallel to each other because they're all interconnected. When the chicken head deflects, it deflects like this, like a Cheshire cat's smile. And then there's more opportunities for leakage for chicken head, depending, and in order to make it more sealed, you probably will have to have a wider joint. They would use a different arrangement for movement, so you can have a more clashes like that. This one on the right is the chicken head. This one on the left is the sword connection. They never go between each other, so the sword connection will never have this issue. They will never clash as the building deflect, and there is not.
So your preference is this sword approach over the chicken head approach.
The thing is, I will be biased to say that because I have never done a chicken head job, so I don't know. I just know what could go wrong with both.
Sure. So let's focus on the sword approach. In this case, where it is a gasketed connection, but you're still relying on your field seals. You're saying in the design process, if you're not accurately accounted for building movement or deflection, what could happen? Could you get torn gaskets? Could you get torn sealant joints? What would be the cause of failure?
Sure. So when if let's say it's a 50 millimeter joint, and this is the standard system, it's not branded, just whatever the system is. If we compress it by 5 millimeters of deflection, that is movement intolerance is induced by long-term dead load deflection and life load deflection. So you get 5 millimeters. If you increase it further, the gasket fails, it only decreases to 10. So you have to be very careful because the gasket could fail. Or if it expands more than 7 millimeters, if it goes, so the gasket will pop out and you're going to get your air leakage and your seal will no longer work. So that would be the issue. So you always have to counteract for that. So you always have to know how much the system can accommodate. But you can change the different selection of gaskets. You can just increase the gasket. Where you kind of locked, and again, I'm not specialist in chicken head. I only can say that basically, if the facade deflects by 10 millimeters, it's okay, but then it's not only the gasket is compressed. You're already at the end of your range.
So in essence, when the units are installed before you stack the subsequent units on the next floors, what you can do, as I was going to say, is a QA/QC measure, but you would call it policing measure, is you can go around the floor and measure that stack joint to ensure that you're getting adequate engagement. So I think that is what can tell you if you're within that system tolerance.
But then you just put a massive jacuzzi and a piano and a party of 50 people, and the slab deflects, and then that's it. Your facade no longer works. So there's how much you can do. So again, that depends on the system, and these are just generics to explain how the movement intolerances work. From this is visuals from our course, just to explain how you can counteract. So this is only so much. You only are compensating for instantaneous dead load of the facade via bracket. Everything else in the unitized system is done with gaskets. So the compensation for deflection for everything else happens through gaskets. It's the same for precast concrete. You're going to go back to wet seal joint. It also would be the same for the precast concrete. So I would say that there's not necessarily, while we are probably at that kind of a topic, I'm probably going to go and show how the precast concrete deals with drainage and for this particular element.
Yeah, before we get into that detail, I find it interesting, or what I'm gathering is that there are trade-offs, and there's really no perfect approach. There are pros and cons to each system type, and there are potential for failure or risk issues if not monitored or policed in the field for both system types. So designing adequately to account for building movements and tolerances and structural loads, as well as monitoring in the field, is heavily required for both to execute.
Yeah, sure. But then when you are not suspended by via rope, it's sure a hell of a lot easier to police it. But when you have to, if you're using unitized brackets, so that's fine. Now, this is how the precast concrete drainage joints work. So you have your first stage seal between the precast concrete panel. There's the second one, and you allow for drainage. Now it looks very nice, drainage horizontally, and here is the drainage vertically.
Now it looks very nice. So what am I looking at? Is this 3 lines of sealant?
It's 2. So this is the backing rod. Oh, actually, it's kind of 3, but it's just modeled incorrectly. Ignore that. So basically, it's a backing rod. This is the second backing rod, and this is just a sealant. It's just a bug in the soil.
Sure. Okay. So then you weep that outer line.
Yes, you weep that outer line. You just basically get this. So you get the water that go through the vertical joints sometimes. Usually that never really happens. I haven't actually seen anyone doing that.
How often do you weep? Do you weep horizontally or all the way at the bottom of the building?
No, every horizontal joint is drained. Every single joint, this probably works the same way as the double stage seal, the same way as your window would do, or like gasketed approach. So the wet seal will happen like that. But then again, you probably nailed it. It's just basically policing that is installed correctly, because when this joint is installed, and if it's done via rope abseiling by an operative on site, he's there alone, or she, suspended by a rope. There is no one actually checking how it's done, unless they just take a photograph of what they just currently done and send it. But other than that, you only find out it wasn't done correctly when it fails.
So what about that gap between the 2-stage sealant joint? Is there a nominal dimension? Is that important?
I have seen this being done. This is just a diagrammatic. It's never really done all the way to the close to the edge, panel edge, because if you're going to do it like that, the backing rod may just pop out, and you will not incorrectly install your seal and make leak. So they are actually usually quite close to another. And off the top of my head, I don't know what's the minimum dimension.
Yeah, I mean, if you think about it, they have to be able to get a nozzle in there to be able to execute the sealant joint.
Yes, and once you put a nozzle in there, you never know how much silicone you actually have applied, and if you haven't clogged the joint. It's probably a very onerous procedure, especially if you're suspended by a rope, trying to position again, once you're installing that rod, only on this diagram it's perfect. When you're actually installing this, it's going to be all over like, oh, sorry, just brush. It's going to be all over like that.
So let me ask this. If you install weep holes too frequently, in my eyes, or drainage means of drainage, whatever it is, a weep tube or a weep hole, if it's installed too frequently, if you have any imperfections on that interior seal or any pinholes, wouldn't you get water or air sucking through because of a pressure differential from your interior to the exterior?
If your air, the secondary seal, would be applied correctly, I wouldn't necessarily see that as an issue.
If it were to be applied correctly in the field, so we're relying on a perfect seal with no imperfections.
Yes, but then again, and I have to be very careful here. Where is the actual additional airtight layer here? The precast is very sensitive in that sense.
I guess my question would be, what would be the point of introducing those weep tubes? I mean, if there's a pinhole or droplets of water, wouldn't it just dry out over time in the cavity? I feel like by penetrating your sealant joint, you're in essence sort of defeating the purpose of having a barrier type system.
well, if there's any condensation happens in that location here, right?
Yep.
So you are much better to allow it to get out. How much rain can go through the sweep holes? Virtually none. And they probably, because there's no, we have to understand also that there would be also a, what would be, behind that element here, there will be also a vapor control barrier in that location here, which is, there'll be a vapor control barrier here, so it will add additional kind of layer of protection for air. It's not there for that particular purpose, but you don't expect that to fail either. So I don't necessarily see that there will be a wind-driven rain through 20 millimeter weep hole, which is not going to be, it's going to be like 10
more so
millimeter.
air. I would think if you have it all the way, so the water would drain down the vertical cavity and then make its way out the bottom horizontal, that makes sense to me. I'm saying if you were to introduce weep tubes or weep holes at every single floor, at every single joint, I think all of a sudden you're creating potential for air infiltration.
Potentially, it's fine. I would say that I haven't actually seen anyone in the UK on the projects I was involved in to introduce the vertical drainage joint. I'm just saying
Right.
that it is happening. Usually it's just these at the horizontal ones. And these are needed because you just don't want the water to pond in that area here. You just don't want the water to stay here. So you want it to escape. So potentially just these tubes within the horizontal joint would be just sufficient.
Right.
Yeah, that would be my answer for that. It's either or. Potentially when the vertical joint would be required is maybe if there's some design elements when the horizontal joint is not an option, if you can't provide it, maybe there's two vertical columns, precast columns there, so that may be the issue. Yes.
So what are some things, I enjoyed some of the pros and cons of the wet seal versus dry seal, what we describe here. What are some things that you wish the UK market could adopt from the States, building practices, system designs, and then vice versa? Where do you think we're being too stubborn and what do we need to learn on our end?
I wouldn't necessarily think that there's anything. The precast and unitized facade, both countries, from at least from what I see, just from online resources, they are fairly advanced. I don't think there isn't anything particular to point at. I would say is UK would be definitely far more advanced in the fire safety, and that would be applied to facades in general. The presence of combustible materials within facades in general. Drainage-wise, I don't necessarily see that. I'm not exposed to any failures. I mean, it's from our standpoint that because when we see that horrible failures happening in the UK or in Europe in general, and because you're just more exposed to it, it's a kind of a expert bias when you just exposed to so many issues and you think everyone has the same ones. You're not exposed to these issues in States. It doesn't mean that they don't exist. We're not exposed to them. They may be as well. But we definitely can see from just photographs from LinkedIn that fire safety needs to be looked at by states. Another thing is corrosion, presence of galvanized materials. Another thing would be presence of vapor control barriers, and depending on the vapor control layers in certain facade assemblies, in combination with fire stops. I think that this detail is often overlooked in States from drawings that I see being posted. I can see that not necessarily this is understood correctly. Yes, these two, dependence of facade assemblies, precast-wise, on the location of vapor control barriers, depending on the climate.
Sure.
And I think that where states need to look at is Australia, climate-wise, not UK. UK, we have basically the same climate as you probably have in Maine, Minnesota, I would imagine. But a building, I would assume in New Mexico or Texas, would need to look at Australia. And
Sure.
where you position your vapor control barrier would not, you don't copy our details so you are from these regions.
No one size fits all. It's funny.
Yeah.
Uh, all right, where can people find your resources and anything regarding your course? From the small amount that I found online, it's been incredibly helpful.
It's ist.uk. Right now there is a Applied Facade Engineering course. It's open for registration for next year. This year is sold out, and the first round of the next year in January is also sold out. But I think that we are running another one in March or April. There are still some places available, and this is not just UK. We're limiting it. Actually, in fact, that there's mainly our audience is from North America, Eastern Europe, and Southern Europe, and UAE is quite present, and the current participants are finding it quite useful. So it's not necessarily just to the UK course. So I would encourage everyone to have a look at it.
Good. So for anybody listening, Eugene is awesome when it comes to technical detailing and getting really in the weeds. So Eugene, thanks for hopping on. Had a great chat.
Thank you very much. Thank you for having me. Thank you.
Cheers.